Hello everyone, my name is P. Srinivaslu. Now I'll take you through my major project, cancer prediction using convolutional neural network algorithm. Abstract. Breast cancer is one of the most prevalent malignancies amongst men and women. Currently, it has become the most common health issue all over the world with its drastic increase in death rate every year. Early detection of breast cancer provides high treatment efficiency and better healing chances. The main contribution of this work is to find a model which is more accurate for predicting the type of tumor cell. ANOVA F-test feature selection is applied to Wisconsin breast cancer dataset to select the subsets of input features that are most relevant to target variable. I compared various machine learning algorithms like support vector machine, k nearest neighbor, decision tree, logistic regression, Gaussian naive Bayes, random forest regression, and XGBoost classifier algorithm. It obtained a highest accuracy of 98.25% in XGBoost classifier as it uses ensemble techniques and is a very powerful classifier. Objectives. Aim of the project. The primary goal of this research is to see how accurate the proposed model is at diagnosing the disease and obtaining excellent accuracy while keeping the latency to a minimum, to discuss the current difficulties and breakthroughs in breast cancer research that leads to important discoveries, to improve the responsiveness and efficiency of the proposed system. Scope of the project. The proposed model has a high degree of accuracy in predicting malignant tumors in their early stages. Another objective of this model is to provide a method for assisting interpretation through computerized image analysis. It could be used to enhance health policy by preventing hospital errors, early sickness detection, and prevent hospital deaths. Introduction. The current survival rate of breast cancer at late stage is low, that is 30%. The early and accurate detection plays a vital role in improving the prognosis and raising the survival rate in patients up to 50%. Proper diagnosis of breast cancer requires correct identification at early stages of cancer, also identifying its category. Different medical images are commonly used for effective breast cancer diagnosis than any other breast cancer testing methods. Medical imaging modalities such as histopathology images, breast X-ray images, sonograms, and magnetic resonance imaging, which is known as MRI, are broadly used for breast cancer diagnosis. A professional pathologist's experience and subject knowledge are required for a reliable breast cancer diagnosis. Without these, in most cases, misdiagnosis occurs, especially in the early stages of breast cancer. It is readily available, fast, reliable, and affordable system for early breast cancer diagnosis. CAD has been developed during the last decade and has shown advancement in breast cancer detection accuracy by more than 20%. Literature review. These are some papers. Data mining techniques for diagnosis and prognosis of cancer published at International Journal of Advanced Research in Computer and Communication Engineering. In this paper, they have presented a diagnostic system using classification and association approach in data mining. The authors have used fraudulent frequent pattern in association rule mining for classifying the pattern prediction of breast cancer through classification algorithms. The authors have claimed that their algorithm is able to achieve 94% of prediction accuracy. Coming to design and methodologies, the first methodology is data preprocessing and segmentation. This procedure begins by importing the required modules from the source libraries. The first step of image processing, it must be done on digitalized images in order to minimize noise and improve the quality of image. The data is cleaned and pre-processed at this stage, where missing and null value records are dropped. In general, the segmentation of images is a way of separating the images into homogeneous areas, but the unity of no two adjacent area converts homogeneous. Segmentation is mainly concerned with extraction or removal of suspected regions or mass of the tissue region of interest from the image. This stage is used to classify anomalies containing suspicious regions of interest, that is ROI. Following the completion of data pre-processing, the step of model selection for classification starts. Feature extraction. After segmenting the mass of ROIs, we calculate several features related to boundaries, geometry, and texture and its neighboring areas. We all know the typical benign mass has a round, smooth, well circumscribed boundary, while boundary of the malignant tumor is typically specules rough and blurred. Therefore, to describe the masses as malignant or benign, we can use a boundary examination. To explain the shape of mass contour, geometry features are extracted. These are calculated from segmentation's boundary pixels. Hence, for mass classification, we also use texture features. K nearest neighbors classifier. KNN classifier is known way for discriminating between healthy and deceased cases after selection of features. However, it also generates competitive outcomes, and in some cases, when clearly combined with prior experience, the state of art has improved considerably. Most KNN classifiers use simple Euclidean metrics to quantify the difference between examples represented as vector inputs in absence of prior information. The prediction module. The capacity to detect liver illness early on is critical in determining the best treatment plan for the patient. Because the gradient boosting classifier beats the state-of-the-art approaches in reliably predicting outcomes, it is employed extensively in this model. When the model gets an input, the numeric values are passed and machine learning algorithm, in this instance gradient boosting, classifies the input data and predicts whether a person has liver condition or not. The model also allows us to generate an accurate estimate of the number of individuals who will be impacted in certain ways. Machine learning and feature engineering might be time consuming process that you do not want to repeat in event of notebook shutdown. As a result, storing it in a reusable format is advantageous. It enables us to preserve the trained model and reload it anytime fresh data is available to test it on. The application will serve as a virtual assistant in big clinical labs, hospitals, and medical clinics. Implementation. This is the architecture diagram. This is the data flow diagram 0. And this is data flow diagram 1. And this is the sequence diagram. And this is the ER diagram. And coming to input and output, this is the view of our web page where the input values are entered and it is predicted, and you will get an output if you are suffering from breast cancer or not. Conclusion. In the project, I have presented an improved classification expert system for breast cancer using machine learning techniques. The project aims to explore innovative approaches for breast cancer classification by adapting the latest machine learning mechanisms. This proposed method has achieved high performance by combining deep learning feature extraction and XGBoost classifier for classification problems. Future enhancements. To enhance the size of training dataset, they can be considered a part of it. Regarding the usage of GINs in therapeutic application, expert might be consulted. It is possible that this will be tested in future. I propose machine learning and novel intricate neuronal setup based on multi-model sickness hazard forecasting algorithm that uses both organized and unorganized hospital data in this paper. It does not focus on various types of data in region of healthcare pharmaceutical information analysis in present work. When the prevision quality of projected algorithm is compared to the uni-model sickness illness risk prediction algorithm based on CNN UDRP, the prevision quality of this projected algorithm achieves 94.8% by pace of convergence, which is faster than the uni-model illness risk prediction algorithm based on CNN UDRP. These are some web references or video links. And some reference papers. Thank you. Now I'll take you through implementation of this project. These are the required files. Now I'll execute this using Anaconda prompt. I'll copy its local host address and open it in a browser.